I've had a lot of trouble with Project 5. As you know, the thing I put in there to be Project 5 turned out to be impossible to do on campus because City College blocks TeamViewer. But that was the one I showed you last week where you test this new vulnerability report saying TeamViewer has a vulnerability because you can see this user ID and password in the RAM, and that is something we should know how to do. So you can harvest the RAM for just one process and find that junk in RAM, and that works fine, but you can't do it on campus because we block TeamViewer here. So I made it extra credit for that reason. But I wrote another Project 5. I have a bunch of old projects. This one here I took away years ago because it didn't work on the server version, but I finally found out why. The Prefetch Folder is the Windows feature that fetches things from and puts them in RAM because it thinks you might use them pretty soon. So it keeps track of everything you use frequently in order to do that. And so in this case, I found out how to turn on this feature called Superfetch on the server version. So your server machines, you have to do this adjustment to the registry, and then after you do that, it then acts like a desktop machine, like Windows 7 or Windows 10, and it fills up the Prefetch folder. So after you do that and restart your machine, you will see a list in the C Windows Prefetch folder of everything you've done. This is what the computer automatically did. It started a bunch of services. These are all the things that were launched when you reboot. The only one that's easy to read is Explorer and Google Update, so I've got probably Chrome on the system, and it tries to update every time I reboot. And Windows Explorer is the main process that draws the desktop and the start button, so whenever you log in, that launches. And that's what I'm seeing here. So now if you go launch some programs like Calculator, WordPad, and DXDiag, or just random Windows programs, then close them, and you'll see them right together, showing when they were launched, and these shortcuts also show what user was logged in when they were launched, so this thing is great for forensics. And so it's good to see. It's a very common place. Look in the Prefetch folder, it's mentioned frequently in your book. It's a simple, easy place to go to see what people have been doing. Another one that's fun is thumbnail cache. This was a really big deal back in the days when the #1 FBI priority was child pornography, and all the forensics classes were all about child pornography, because this shows what images somebody's been looking at. And that was a big issue in that case. And the point of this is that if you, so we make an image with your name on it and save it, and then view it. What you do, now there's another feature in the client version of Windows that's not in the server version, where when you view an image, it shows a preview of the image. So you have to turn that on also, which I found out how to do. And then when you click an image, it will put a preview down here, your name. The point is, when you delete the image, the previews are not deleted. This is also true of the iPhone and the iPad. If you open an iPhone app like a browser and you switch to some other app like a music player, it has an animation where the picture goes whoop to shrink down. So in order to do that, it saves an image of your desktop. It saves a whole bunch of those, and they last for a long time. So there's a graphic copy of what every screen looked like as you use your iPhone, and forensic examiners can find it, which is bloody awesome. You can see what people have been typing into messages and emails and stuff. And your Windows is the same. So then you go delete this file, put it in a recycle bin, and empty the recycle bin, so it's gone. But there still are these files. Microsoft hides them pretty deep. It's C, user, student, app data, local, Microsoft, Windows Explorer. You dig all the way down here, and you find these thumb cache files that store the thumbnails in a sort of database format, in a series of files. And you can't even view these easily. You have to download a special viewer to view them. But if you get Thumb Cache Viewer, you can now see the file names of them and sort them. And if you sort them by size, most of them are size 0. So if you just get the ones that aren't size 0, this one is my desktop image, and the second one was this image. So this is how you can recover low-resolution copies of what images someone has been viewing, even when they delete them, which is really pretty handy. And there's a ton of things like this in Windows. Yeah.
Would that require you to show hidden files ahead of time? Do you have that?
To do what files?
Show hidden files via the folder options?
Yes, unless you use like the command line to get there. Because you can't see those files, right? You got to show hidden files and hidden protected operating system files to get here. Yeah. Yeah.
It's on the app data.
What's that?
I saw the app data, so you know.
That's right. That's the app data. Yeah, the app data you can't get into normally. All right. Anyway, so those are fun ones to do. And number 5, I didn't make it due for like another 3 weeks because, you know, we've already passed when 5 would have been due, or it would have been this week or something. So I put it several weeks ahead. But you have plenty of time to do it. It's not that hard to do either. But these are cute little tricks to learn, and there's a lot of them. So I'll hopefully keep those coming. Anyway, let me find my slides, which are here. There we are. All right. So let's talk about duplication, and let me go through my usual song and dance of trying to figure out where to hide this thing. All right, so, all right. It always takes me a couple tries to learn where to hide that thing. All right, so, whoa, that's not right. There we go. Okay. All right, so a static image is the original computer forensic image that was the standard in the business until maybe 5 or 6 years ago, where you count a computer, if it's on, you just pull out the plug, you don't even log out or anything because you just don't want it to you don't want to change anything. And the reason they did this is not because they were stupid, but because until recently the rules were nothing in RAM matters anyway. Because nothing in RAM has an owner or a timestamp, so you can't prove who put it there or when it got there. So even if you found something horrible in RAM, it wouldn't prove anything, so why waste your time? But that was before they were thinking about things like incident response. Yeah?
I mean, that is a common practice even just until maybe 2 years ago.
Oh, a lot of people still continue the old practice.
No, we still do that. When I was at Richmond PD. That's
Yeah.
whenever I served warrants and like that for certain things, that's what we were told to do
Yeah.
back into, recently. And even with cell phones, we just collected them, hooked them up to Cellbrite, they ripped everything, and then
Right.
we have other images for that.
Right, and I mean, that has been the standard for a long time. It's very easy for first responders to pull out the plug and bring the thing in, but you lose the contents of RAM, and now people are moving into that, especially, so for criminal investigations, it's still true that most of what's in RAM doesn't matter. But I think it does increasingly these days, like I mentioned, for things like pedophile cases, you want to catch them in the process of downloading the stuff and get it from RAM, then you really know.
Now, that go around while you certain warrants for certain things that's specifically there to collect it. So it's not even normal beat cops that are doing that.
Yes, that's right.
People doing that stuff.
That's right. And that's, of course, a big issue. You want to have some simple way for first responders to grab the data and preserve it long enough to get it back to the lab. And there have been different schools of thought on that. For a while, Microsoft had a tool called Coffee, Computer Assistance for Law Enforcement or something, which was a version of Windows that was forensically sound, and you could boot a Windows-like utility. It was basically the same thing you get with like Kali. You could boot a utility that would then make images of things with the Write Protect turned off. And they would only give it to law enforcement officials, and somebody had like a slide that made it sound like it could image BitLocker, encrypted volumes, and there was a brief period of time when people freaked out and said there was a backdoor in BitLocker, but it turned out to none of it be true. It just does the same stuff we could do in a Windows environment. Anyway, so a hardware write blocker, mentioned before, this is what all the pros use because you really want to be sure that you do not alter the data while imaging it, and the only way to do that is with a piece of hardware. So let me see if I can find somewhere to hide this idiotic thing that's always in my way. So it's a little gadget you get like this. It costs about $300, and you have to get a pile of them for all the different connector types. It really runs into money pretty fast. It has to have about 1 gigabyte of memory in there and a processor in order to interpret the signals coming from the computer and lie to it, to tell the computer, okay, I created a recycle bin, I updated the journal, I changed the timestamp, yes sir, without really doing any of that. Yeah?
Isn't there a way, I'm not sure, just to like put like a jumper on some of the pins to make it unwritable or something?
Back in the old days, before SATA, when there was PETA, when there was a 23-pin connector, you could cut one of those wires. That's the really old days. So if you have the old IDE drives, back when drives were like 50 megabytes, you could do it. Yeah?
Did you accidentally delete something on your PowerPoint or no?
What's that?
Did you accidentally delete something on your
No, I don't think so. But maybe I did. I certainly could have.
You did.
Maybe I did. Good, let's go back and see. That could certainly happen. Oh yeah, thank you, good, all right. Good, might as well keep it. All right, anyway, so, all right, so those are write blockers. Your book has mentioned big industry leaders, Tableau and Wybertech are the companies that sell these. There's a lot of them. I'm not aware of any cheap alternatives except software write blocking. By the way, one of the candidates for Project 5 I already had to reject was USB write blocking with a registry hack. There's a well-known registry hack that forensic investigators use if they're really cheap, where you change a registry key and Windows can no longer write out the USB port, which sounds good, but it totally didn't work. Ron was doing it in the lab and it totally quit working, and that's the problem. It's not an official Microsoft feature, it's not documented, it's just something people found, and you really don't know how long it's gonna work. This is pretty sleazy. This is why the pros will mock you if you use a sleazy technique like that instead of getting a real write blocker. And by the way, you have to test your write blockers. They fail. And you don't want to find out the hard way. So there's like 10 basic steps, and one of them is check your write blocker before you use it on a drive that doesn't matter, so you know it's working. We're going to use Deft, one of the forensic distributions. This one's from Italy. There's a bunch of them. This one's fine. You boot from this. This is an altered version of Linux that does not write on any of the drives while it boots up. They've just taken away all the features that would change the contents in the drive, and that's the point. So it is built into this. As long as you're booting from the disk or from an ISO image, you'll be able to take images. You can make images with a variety of tools. You can use FTK Imager or Encase if you're running on Windows. If you're running on Linux, you could use DD, or you could use the enhanced versions like DC3DD that add a few features to DD, like storing the hash and such. Yeah.
Two question on Encase of all
Yeah.
things, two modes, right? Acquisition and forensics.
Right.
And to get forensics, do you need to have some type of key, or how do you get forensics? Because it's easy to get acquisition mode without any kind of certificate or whatever you have.
According to the book, the book says you can't use any Encase forensic tools without purchasing some version of it. The forensics version is more expensive, and the enterprise version is more expensive. They're different, but I think they all give you acquisition tools because they think you might want to just be a first responder, and then you hand it to some department, and they're the ones that will buy the fancier version. But you have to pay something. They don't give you any free tools. FTK gives you a free acquisition tool, but you have to pay for the analysis tool. Anyway, all right, by the way, there are hardware disk duplicators. If you really get a pro, you pay a lot of money, you get just a hardware device. They'll copy the disk to here. It's easy to use. It's more expensive, but it saves time, and it's more accurate because it's not as easy to make some kind of mistake. So here's your issues. Make sure your source media is write protected so you're not changing it. Make sure your examination environment is not going to change anything. If for some reason you can't use a hardware write blocker, for example, you might be imaging something like a Mac, where it's pretty hard to take it apart and get at the drive. Then you might want to do something else, then use a hardware write blocker, and then you're going to try and use software that won't do that. Make sure you have somewhere to store the output files. It can be very big. If you're using DD, it's going to be as big as the total storage on the device. Make sure this means, by the way, that's why it's intrinsically dangerous. You have to be writing to a drive somewhere. You have to connect the evidence drive and copy. You have to connect the evidence drive. You have to connect an acquisition drive and copy from here to there. So you can't just turn off all writing. You have to be sure you're not to get them backwards. And it's very easy if you use something like command line DD to just make the mistake and copy your acquisition drive on top of the evidence. And that is a forensic erase, and then it's gone. So you're really not going to please your client when you tell them you did that. Anyway, if you're using command line tools and command line options, you better be good enough at it not to get it backwards. So DD is included in all Linux systems. It's been around forever. It's available, but the problem is it doesn't give you much feedback, so you don't really know if it's working, and it doesn't create the hash value, so they made these slightly modified versions from the DoD and the Defense Cybercrime Center, and those just do write more feedback out and create another file with the hash values in there. So there's the problem. As soon as you boot up a system, every connected drive gets written on. That's the way operating systems have been for a long time. So your best defense is a hardware write blocker. And the next good option is a forensic DVD, where you boot a special version of Linux that doesn't write. That's pretty good. The only thing that can go wrong there is if you don't have the boot order set correctly, and instead of booting your CD, it boots from the hard drive, and you don't notice that fast enough, it's going to be altering your evidence, and you will look like a fool, saying you damaged the evidence for a stupid reason like that. So Encase has several tools. Directly in Windows, you can also give you a Linux-based boot disk, but you're not supposed to use any of these things without paying for Encase. Then there's live imaging. You can, while people are using the system, you can make a copy of the hard drive. This is called a smear, because if it takes you an hour to make the copy, you're getting different versions of the files as you go through. People are changing the files while you're reading them. So this is not as perfect at all, but it is evidence that came from the drive. It does include information that you want. You just have to know what it is. If you make a second copy, you're not going to get the same MD5 hash because it keeps changing all the time. So this is something, it's certainly not as perfect and clean as a static image, but it's an option. If you have something like a business critical server that they are not willing to take down and you want to get evidence off it, you could do this. Another thing people like to do is you go the other way we were talking about on that quiz. You decide you're worried about insiders. So now you have like suspects, and you want to make a copy of their machine without them knowing, because you don't want to hurt their morale by having them find out they were under suspicion. So you can connect and suck it through the wire in the business day while they're working, and they will never know you did it. And then only if you find evidence do you then take the one guilty one and tell them the others you hope they never found out that they were being investigated. They did that to me here at one time. They got upset. I've many scandals centered around me at the college, and at one point they got upset about me and they stuck a covert imager on my machine to image everything I did.
How long did it take you to find it?
Somebody told me, and then I found it, and I never used that machine anyway, but it didn't matter. It wasn't doing anything bad either. But anyway, you know, they certainly could have got me all upset, you know. But I got a thick skin. Anyway, you got to have a thick skin in this business. Anyway, you get a lot of insults. You can't let it stop you. Yeah.
How do you do the live imaging? So how do you log into that? How do you?
Well, you have to connect to it and run a process on the system, like FTK Imager can do it. You connect and you image it while it's on.
Do you need to, like,
That's what we did in the first project. You did a live image of RAM by just running it on the system, and you could have done it with, you could have imaged the hard drive. And what you do is if you get the enterprise forensic version, it has the ability to push an agent onto it over the network, which you then install, which then you run. And that's, by the way, how bad guys steal things. They put a Trojan on there, and then they run the Trojan, and the Trojan takes the data and sends it over the network. And we'll do it with an Android phone. In the projects later, you'll do it with network acquisition. It's very easy. You just run DD, and you pipe it to Netcat, and you send it over the wire. And if you're picky, you then put it in something like SSH, so it's encrypted. But if you're a slob, you just send it in plain text over the network and get it. And it works. Of course, if somebody breaks the network connection or stops the process, it'll stop. But this is typical hacker stuff. You get it, come to click on a link, you put on malware, you remote control their machine to some extent. And you suck the data off their machine. This is just what the bad guys do all the time, and the good guys can do the same thing. And if you pay for in case, you get professional commercial tools to do it. So, all right, so live image, you got no RightBlocker. The system is obviously being changed. You are running a process on that system, so some of those changes are changes you made, so not everything you're finding is the result of the suspect, but you just have to be smart enough to understand how to tell the difference. You might make the thing crash, you might destroy evidence. You should not be saving your copy on the local system or saving anything on the local system because that destroys evidence. And so the best thing is run FTK Imager Lite. FTK Imager has an installed version where you install it like an application and then run it, and that's the wrong thing to do because that writes on the disk, overwriting sectors that might include evidence. The right thing to do is run FTK Lite, which we used, which runs from the removable media or network share, so it does not install anything, so it doesn't write as much on the disk. And then you suck the data over the network or USB port or something, so you aren't actually saving it on the evidence drive, overwriting sectors that might include evidence. And then there's Apple hardware. Apple sends things like the Apple MacBook Air. Is this miniaturized thing. It's hard to take apart. It's hard to get at the drive. It uses strange internal connectors and strange formats, and in general, you have to buy expensive stuff to deal with it. So one simple thing is reboot into target disk mode. Apple has this option. It's a boot option, and then your whole machine is just like a USB drive. You just have a FireWire or Thunderbolt port, and you can read and write on it just like a USB drive. Then you can just image it through that. Very handy. And Tableau will actually sell you a FireWire RightBlocker. I don't know if anybody has a Thunderbolt RightBlocker yet, but there's certainly a market for it. A lot of people use Macs. Probably somebody will sell it to you, but I don't know. And if you have something big like a RAID or a SAN or a NAS, it's very often not worth it at all to try to make complete images and try to figure out what goofy proprietary format they use. They're typically not just FAT32 or NTFS. They typically have some screwed up proprietary way of indexing the data and assigning the file names and distributing it across all the platters, and you'd have to figure all that out. Like we were saying before, if I had a job like that, I would just outsource it to Drive Savers. Drive Savers is expensive, but they know all that stuff. And unless you're going to be doing a lot of them, it's really not worth the bother to learn all that stuff. They made a kind of fun capture the flag problem. This is one about 2 weeks ago. We had to capture the flag. They gave us a RAID image, and you had to figure out how to put it back together to reconstruct the files. And I did it with Python. It took a while. It was pretty fun. Anyway, so FTK, you can, if you do a logical image, you say, well, I'll settle for just the images in this folder. So it'll copy the images, and then it will put it in a container and put a hash on it. So you can prove that you made good copies of it and such. And often you just do live imaging. If you really want an image of the hard drive, you might just do a live image, because that will convert it into data you can read instead of you having to actually read it in the original disk format. That's what the logical image. The live image would in fact be in the original proprietary format. So that might be the best answer anyway, rather than figuring out how to connect directly to it and bring it down. If you really want to copy the drive, you might do a live image copy. These are options. It's good to know them all and then choose the one appropriate for your situation. And then there's virtual machines. This is one of those rare things that makes life easy. You know, a virtual machine is just a bunch of files on the disk. Here's a virtual machine. It's just got a virtual memory file up top that's 2 gigs. That's the virtual memory bit by bit. It's got a bunch of VMDK files. Those are the hard disk, conveniently broke up into little files. Then it's got a few other configuration files and log files, and that's a virtual machine. So if you just suspend a virtual machine, it saves the current state of the hard drive and the memory right there in a file. You don't need to run any acquisition tool at all. You just copy these files, and there it is. So virtual machines actually make our life much easier. That vmem file is exactly what you would have got if you were able to do an image of RAM without altering it. And we didn't have to run any forensic tools or modify it at all. This is probably the only case I know where you could have a RAM image that is a static image that can be reproduced, that's perfect, that doesn't include any changes you made. So that's kind of cool. Of course, there are imperfections in virtualization software, and the virtualization does not completely separate that machine from the host, and there's malware that leaks across and attacks that leak across, so nothing is ever perfect, but that's sure easy. You can just make a straight copy of virtual machine, and that's it. That is a forensically sound copy. Anyway, so that's kind of fun.
One
Yeah.
question about that, what about when it's not shut down properly, the machine state's not saved?
Right, if you don't shut it down and it's live, then you've got something like a live RAM image. And, but anyway, it's still, whatever you get, you can put a hash on it and call it that your evidence, then you can make more copies of it. But yeah, that's an issue. If you didn't suspend it, then I guess it would still be changing and you'd have a smear or something. I'm not quite sure what you'd have.
You could just take a snapshot.
Yeah, you could take a snapshot. That would be another good option. Yeah, although no, actually a snapshot, from what I understand, snapshots don't really store everything. You only store the difference between it and something else to save RAM, so it would really be hard to use.
The original test of that.
Yeah, and then you'd have to reconstruct it. Yeah. Anyway, but now almost everything is virtual. Almost every server you're connecting to is in fact virtual, so this is more of an option. And I got a few more iClickers. This may be the end of it. I think it is. Then I just want to demonstrate some of this stuff. All right. So, which one is software included in every Linux system? All right, I'll quit at 30. All right, and that is DD, just a fundamental system utility like cat or anything included in everything. All right, which one is free Windows software? All right, looks like I can quit at 30. All right, and that's FTK Imager, of course, you've been using it. All right. And which one lets you make a valid forensic image just by copying some files? Quit at 30. All right, and those are virtual machines. Good. All right. And which one is particularly helpful on Macs? And that's the target disk mode. Lets you connect it through a removable device port and image the drive. All right. Let me talk a bit about the next project. I just want to point out some gotchas here. If you haven't, I know some people are not very familiar with virtual machines, so this one may be kind of frustrating. And this is the one directly related to static acquisitions way down here at project 10, because I keep changing textbooks, so the order of the projects keep changing. So the order doesn't match the order of your chapters too well. But this is where we do static acquisition. And so a lot of students get confused, so I want to go through the steps here. There's a thing here called an evidence file. Now this is a zipped small hard disk, only 100 megabytes, just to avoid wasting a lot of time. So you have to download this thing, and you have to unzip it. And when you unzip it, it's a normal zip file, so it'll unzip in any operating system easily. You get this thing, Windows 2000 Professional sparse2.vmdk. This is a VMware format that doesn't save unnecessary extra copies of zeros to make it smaller, easier to move around. So this is only 1 megabyte, but it's an image of a disk that is 100 megabytes in size. Now, you're going to make an image of this volume. This volume has a few files on it, nothing important. I just want you to get a correct forensic image of this volume without changing it. And the way you do it, if you had a real hardware RightBlocker and a real hardware disk, you could do it. But the way we do it in virtualization software is you make a virtual machine. You make a new virtual machine. Let me just go through it here. File, new virtual machine. And you make a custom virtual machine. And the steps look a little different in Windows, but I've got them in there. But the point is, you make it a Ubuntu virtual machine. Now this is not now that evidence came from Windows machine, but that doesn't matter at all because we are not going to boot that operating system. That's the last thing we want to do because that would modify the disk. We're going to use deft to image it, and deft is Linux. So we want to make a virtual machine prepared for Linux. So we continue, and you create a new virtual disk, and now we're done. Now this, if you try to start this machine now, let me save it someplace. This is demo. Okay, that'll do. I save it good in my VMs folder as demo. All right. Now when it launches, it's not even going to boot up, right? Because I don't have any operating system at all. I made a virtual machine with a blank disk. So this thing is completely useless. But that's the point, because the operating system is going to be on a DVD, and this disk is going to be used to make a copy of the forensic evidence. This is what you do. You put in a blank disk and like a USB port. That's where you're going to put the evidence. Then you boot the computer from a DVD, not using the hard drive, and then you image it onto your blank drive. So it's okay that it won't boot up right now. That's what should happen. I have not yet given it any operating system at all. So to fix that, I have to go adjust the, no operating system was found. That's to be expected. So let's turn it off. Now I need to put in the disk. I have my virtual machine settings here. I'm going to connect the CD, and then I'm going to go to a disk image. I have several thumb drives with deft on them. You can copy them here or copy them. I'll take them to the lab after this because it turned out to be really slow to download. It took me like 2 hours to download it today, which was pretty frustrating. This deft 8.2, they seem to have rotten networking up there. Anyway, so you get this ISO, and now I have connected my virtual CD to that ISO. So now when I restart the machine, now it's going to boot up to deft. Now I'm not going to continue because I haven't connected the evidence drive yet. But before you connect the evidence, you make sure you've got this working. Because if you're trying to boot from the hard drive, you're not going to be happy about what happens when you plug in that Windows disk. So now I know I got my deft actually working. Now I can connect it to the evidence drive. So all you do is you go into your virtual machine settings and you add another drive, a new hard disk, and you make it an existing hard disk, which I'm having a little trouble with. Let's go back. I must have followed it up somehow.
Maybe click the add device.
Thank you. Oh, well, that's what I should do, add device. But here I had to say new hard disk. Oh, existing hard disk. That's it. Existing hard disk is what I want. Okay. Now I'm going to add that thing I just unzipped, which is in my downloads folder. Here's the thing I just unzipped, this Windows 2000 thing. There. That's the new drive. So I connect, and here I have options to make a copy or share it. I'm just going to share it because I don't have another drive actually using it. That's fine. Either one would work. It doesn't really matter. And now I can apply that, and now I can restart my machine, and now it's got two hard disks. It's got a blank 20 gigabyte hard disk, and it's got the evidence drive here. And but when I boot it, it's going to boot from the CD, so it's not writing on that drive. So now I just press enter to get English, and enter for the default boot up mode, which is all you want, because this thing is specifically designed for forensics, and the default OS is the one that works. And now you can image it with any Linux tool. You could use DD or D3 FDD, but in fact, this thing, which is specifically designed for forensics, gives us a graphical environment. Now, if you are used to using things like Windows and the Mac, you're used to good graphical environments. Linux graphical environments always suck. This is just the fundamental rule. All the pros always use the command line because the graphical environments never work right. This is no exception. You will see how joyous this graphic environment is. I don't know why. There's a fundamental religious decision of the Linux community that only a wimp would use the mouse, so they never make the graphics work. But anyway, so when you get booted for Deft, you will find right on your hard drive the tool you need, Guymager. Now, my I'm probably going to need more of the joy because in this room I have a little other solution. Here's my desktop. So Guymager is the tool. Now the problem is I first have to mount the drive. So the first thing I have to do is run this disks tool. Because right now, everything is not readable and readable. But let's see what disks we have. If you go to Accessories, Deft, Disks, there. This will show me my hard drives. The use of this application could alter the original data. This is the dangerous spot. I do have to write on one of those drives. And I better not be writing on the wrong one, or I'm going to have a bad day. So you have to say, I know what I'm doing. And now, because they don't want to hear it if you write on the wrong drive. One is 21 gigs and the other is 105 megs. This is the evidence drive. That is the new one. So this is the one I want to write on. So that one, I go to format it. Click on the gear.
How did you know which was which?
I'm just by the size. The evidence is 105 megs. If they were the same size, I'd have more of a problem. That's why hardware write blockers are the really good thing. Then you have it in your hand, you plug it in, you know which one, then you can't foul up with any software mistake. This kind of stuff we're doing here is for small shops and amateurs where you use a Linux boot disk. Real people cough up $300 and get a real hardware write blocker. And then you know. Anyway, so I'm going to format the disk. I'll use the fastest format technique because I don't care. I'm sure I want to format it, warning me, if that's the evidence drive, don't come crying to me. And now I have to make a partition. I could partition the whole thing, but I don't need 20 gigs for this. 500 megs would do. I've only got a 100 meg drive I'm imaging, so let's do that. And I think I call it here, I had a plan. Here, call it data, all right? All right, so I create the format, and now I mount the drive with this button. And now it's mounted. So I can now write to it. I didn't do any of that to this drive, that was the plan. So, that means I now have somewhere to put my data. Okay, let me shrink this down some. All right. So I'm done with all that, now I'm going to acquire it. This is very easy. You're running Guymager. The only problem is the graphics don't fit on the screen, which is a perennial problem with Linux. And by the way, this thing doesn't have VMware tools that work, so you can't make the desktop bigger. If you make it bigger, it doesn't get any more pixels, it just expands like a telescope. So what you have to do is shrink this stuff down to see what you need, because there are all these columns that don't fit on the screen. But fortunately, none of them really matter. The only thing that really matters is I can tell which drive I'm talking about. So this is the one I want to image. So you right-click and acquire the image. And now you just tell it where to put it. So you put in a case number, an evidence number, examiners, your names. I could choose expert witness format or DD. And then I put it someplace. The image directory is there. The image directory is media root data. And you have to choose it with the mouse. Media, root, data. This is the drive where it's going to put my image. That's the destination here.
How do you know that that's the place?
I chose it when I formatted it. I chose what to call it. And it told me where it was going to go in that image processing, in that partitioner tool. It told me where it was, media root data. I didn't point it out, but it was there. That's important, of course. Now you go to file name like demo, and that's it. Now it's going to calculate an MD5, it's going to verify it, all that's fine. I think I'm ready to go. It's going to make an expert witness format. So I start it, it's running, it's done. Because it's so small, it'll happen right away. So now I can go look at what it created. If I open a, I forget what they call this stinking Explorer. Let me get my, another fun thing about Linux, of course, they changed the name of everything in every version, so you can't find anything. Oh, they use the command line here. That's probably the way to do it. We'll use the command line. So that, by the way, they also changed the name of that just to make sure you're always baffled. It's LX terminal, which I'm sure seemed smart to them. Anyway, so, all right. I can't make it bigger or anything. Let's see. Just a moment. That really stinks. Let's see if I can possibly make it bigger. Font. Oh, good. A font number. Can I just make that number bigger? That would be good. Make it bold, maybe. See if it becomes visible.
You should change the color so it's not so.
That would be
Change the
nice.
background from black to white.
That's a good idea. Yeah. Change the background. White doesn't appear to be an option. There's whitish stuff. Let's see what that looks like. Doesn't do a thing. This is what typically happens. I remember other ones you have to display, advanced. All right. Background. Change to that. And
Click inside the triangle towards the corner where the white is.
all right. Good.
Oh,
Thank
the
you.
upper right, the upper right one.
Upper right.
No, like in the triangle, in the upper right.
Oh, this one. Oh, good. Okay. Good. Oh, good. Thank you. All right. Now we can see what we're doing. All right. So now I can CD to. Oh, that's great. No, you still kind of see it. Such is life. Okay. I just want to CD to here, then do ls. There's a thing called data. Okay. Okay. Here's what we got. ls minus l. I've got demo. I got an encased format, which is less than 1 meg because it's zipped, and then I've got some info about it. Let's take a look at that info. And that's Guy Major storing a sort of log file about what it did. And at the end, it's going to have a hash value, an MD5 hash, which tells me if you did it right. And I think this is right. I think 90A is right. I put it in the project what the first few digits of this should be. I just think I'm going to do it again with the other format because it's important to understand the difference here. Let me just minimize this if I could. Is there, don't appear to be the usual buttons? It's just too small. All right. So,
Right there.
yep, it's there. Just, well, that'll do. I'll shove it to the side. All right, let's go back to here and make another image. Right click, acquire image. This is all good. I just want to make a Linux format. And I think I'll give it another file name. This is going to be DD demo. There. That will avoid overwriting the other one. And it's going to split it into 2 gig files, which is the default. That's usually what you want because it's hard to move big files, especially if you pass through like thumb drives, FAT32 volumes and stuff. So I will start it. The file names contain special characters. They do? Oh, for crying out loud. All right, I used a dash. Fine, be that way. DD demo. Okay. Fine. Running, finished. Okay. So now it's done. And let's take a look and see what it has done. If I do, fine. How about I make it big? Plus, perhaps. Double click? Double click works. Hey, neat. All right. So Q will get me out of this. Okay, ls minus l. ls minus l would work better. All right. So you see there's the DD image, which is 100 megabytes. And the compressed version is only 500K because, of course, there's not much evidence here. So that's the raw image, and then it also saved an info file to go next to it. Now this encase file actually includes metadata in the file, which you would see if you opened it in a case. But the DD, of course, does not. It's just a raw image, and that info file is the thing that tells you what it's got. So that's what I wanted to show you, how to make a proper acquisition. And it's such an important skill, you ought to practice it. So when you're done with project 10, go do project X2, where you just make another image. You've got to get the right hash. You've got to get good at making static images. It is a fundamental skill of forensics. Everybody should know how to do that. Even people that know almost nothing about forensics are trained to make static images and take them back to the lab for analysis. You know, this is the first responder stuff. So anyway, it's a thing you should know. And we'll use various tools to analyze these things later. All right. And I might as well mention the command line commands. I think they're in here too. I have DC3DD. Do I have it? We do have DC3DD. Okay, fine. And that shows you how much fun it is. It's already trying to do something and freaking out that I haven't told it what to do. And it won't even cancel. So that was fun. But anyway, you can do this stuff at the command line. DD will make a copy. These other ones, if you give them the right input parameters, will work. But this is the kind of stuff that people don't put up with that pay money for tools, where you give it a stupid command and instead of giving you a help page, it just flies off in an infinite loop. That's why, you know, most people would rather pay a pile of money and get in case than use Linux command line tools. But this graphics tool, Guy Major, makes it somewhat easier to get your image without following up. Anyway, all right. So let me just stop this recording. You see you on the eye clickers, and I'll go to the lab to help anybody that needs help there. This is 121, Chapter 8B.